What's up, guys? It's pretty tough to start a project from scratch, but luckily it's pretty rare. You can usually take code that you've written in the past for a similar project or that somebody else has written in the past and modify it. For example, recently I had to find people for a blood drive and see where they are based on a schedule. Well, I just took code that I had written to do the same thing with delivering flowers on Valentine's Day, and only had to change one or two functions. So in this case, we're going to make Tic-Tac-Toe, and we don't have it, but we have a Connect4 program that I've written in the past, which pretty much does the same job. It's got a grid, you put spots in there, you check for lines and horizontal, vertical, diagonal, and you go back and forth between two players until it's over. So let's make Tic-Tac-Toe, but modify this, which is going to be less work than starting from scratch. For example, at the beginning we make an empty board, and we still need to make an empty board, it's just different dimensions. I'm going to change this to 3 by 3, and here's a big danger: the comments. If you have comments that are old and somebody reads them and they go, wait, 6 by 7, what's going on? They might be confused. So we could just delete the comments, or we could change them to be up to date. I'm going to say, for now, we'll change them. And if I run this, of course it's not going to work all the way through the whole program, but it will. See if I've got 3 rows and 3 columns. And that's being printed by this function, or at least the string is being made by this function called pretty. Do I need to change that? Well, it turns out no, because it doesn't have any numbers in there. In fact, it came originally from a checkerboard program that was 8 by 8, was totally fine doing the Connect4, and was be totally fine doing this. Status, we're going to still do the same idea of printing, hey, this is what we're doing, this is whose turn it is, whatever, but we need to change the specifics. So let's do that. I'm going to say Tic-Tac-Toe, and we're not going to say choose a column, we'll say choose a spot, space, square, tile. That's a question. What do we want to call it? I'll say spot right now, but we'll see how it goes. And it's not really index. I'm gonna say label, because here's what I'm thinking. When we get the input for Connect4, it's just a number because they drop it in a column and they don't choose the row. They let gravity choose the row. But in Tic-Tac-Toe, you have to choose 2 dimensions, and I think it would be annoying to get 2 dimensions separately from the user, where you ask them for a row, you ask them for a column. If there's a problem, you have to start over, or maybe just one again and say, hey, we're keeping column 2, but say the row again. That would be, I think, tedious, especially for the user. They might get annoyed. So what I'm going to do, and this is just a design decision, it's not mathematically determined, but I'm going to make the choice to ask the user for a single number. We'll just tell them, hey, this is 1, 2, 3, 4, 5, 6, 7, 8, 9. And if you want the bottom left, you can say 7. Okay? That's how it is on a phone. It's not how it is on a keyboard, by the way. If I was expecting people to use these numpad keys on the right, well, then I would put 7, 8, 9 on top, because that's how it is with that. I don't think you guys use the numpad very often. I think that's more for older people. So I'm not going to put 7, 8, 9 on top, but it's something to keep in mind. So let's say these labels that were on the bottom, I'm going to move them up here to be near this label idea. And I'm going to say, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Let's see how that looks. So the idea is, okay, yeah, that's missing. This \n character means new line. It's the equivalent of hitting enter or return. And it's not a Python thing. It's this old idea that comes from back when computers had a system called teletype. You hit buttons and it sort of represents what a typewriter would do, even if you're sending signals to some remote location. So I know that looks weird, but the \ns are just a shortcut to avoid writing a giant string that covers different lines. But this is going to say, here's what you are working with, user. If you want the middle, you put 5. okay? And then they'll see the effect when they get X's and O's dropped in there. Okay, are we done with this? I don't know, we can always come back. How about full? The concept of being full is still there, but the concept of dropping into columns is not. So I'm going to get rid of that. How about draw? The concept of draw is important in Tic-Tac-Toe. In fact, it's a lot more important than Connect 4 because I don't think I've ever seen a Connect 4 game fill up with no winners. In Tic-Tac-Toe, that's probably the most common way for the game to end. So I'm just going to say, what if there are no blanks? Okay, meaning if we look through and there are no blanks, then the game's over because you can't take a turn. Now, theoretically, you can predict before then. You could say, well, there's a blank, but it's not going to matter, and we can end the game early, but I'm not going to worry about that. So I'm just going to say blank in row for row in board, meaning if there's a blank in any row, it's not a draw, okay? And I'm going to use the Python function called any, and that will return true if there's a blank anywhere, which is the opposite of what we want, right? We want false if there's a blank anywhere, so I'm going to say not any of that stuff. And this is why people like Python. Look at that. It's English words. It's not exactly English, but it's pretty close to something you might understand. Next we have validate. Well, this is going to be there. We still need to validate inputs, and we reject it if they put hello or give me spot number 20 or something. But I think we're going to have to change it. I'm going to save this one and come back to it later after we look at the main function where we get the input. Dropping, we can delete that because there's no gravity. You don't let the piece fall until it hits something. You just put it in a spot directly. Transpose, this is the idea of sort of flipping on a diagonal axis. If you have a matrix in math class, this is an operation you do a lot. That's why I use the word transpose, because that's what they use. And will that exist to Tic-Tac-Toe? Sure, if we check the rows and we want to check the columns, we can just flip it and then go from there. So that's fine. Diagonal. Here's another thing that we can cut, because in Tic-Tac-Toe, there are two diagonals. It's just two ways that it could possibly go. In Connect 4, it was a lot. It was like several this way and several this way, and they're different lengths. Like there might be 6 in this diagonal, 8 in this one, and you're not looking for the whole thing to be X's. You're looking for just 4 anywhere in the middle of it. So that was a lot more complicated. We had to write code to sort of trace till the end of the line in different ways. But in Tic-Tac-Toe, we can just say, is it these 3 or these 3? And we can just list the possibilities because there's not enough to make it any more complicated than that. So guess what? There we go. It's the best thing in the world to just delete a function because now you don't have to worry about it. It can't have bugs. It can't have errors. It can't send you astray. Okay? So the diagonals, again, we don't need to like start in a corner and trace it along. We can just say, is it these or is it these? I'm going to say, I'm going to return a list of 2 things, and I'm just going to write them directly. So there's board. Okay, remember, in this visual, I called them 1, 2, 3, 4, 5, 6, 7, 8, 9 because that's what the user's going to do. But that's not what we do behind the scenes, okay? When they enter our restaurant and choose from the menu, that's what they know, but behind the scenes we have to do more, like the temperature of the oven and how long it cooks and what kind of knife to use. So behind the scenes we have a different method of holding these rows and columns, which is 2 separate things, row and column. So the top left is 0, 0, the middle is 1, 1, and the bottom right is 2, 2. Right, not very complicated, right? 0, 0, 1, 1, 2, 2. We could have written a loop to do that or something, but it's so short, it's fine. So that's one diagonal, that's the one that goes downhill. And then the one that goes uphill is, well, it still includes the middle, but these other guys are going to have to change because it's 2, and then 0, 2. So there we go. Is that guaranteed? No, I should test it, but since we have this Frankenstein mix of different games right now, it's not going to test very well. I might be able to run with no errors, but it doesn't mean it's going to work. Yeah. So it doesn't know what to do with that input yet. Okay, when is very similar because it's still checking vertical, horizontal, and diagonal. It's still checking for a certain thing in a row, but it's a lot simpler. We have 3, and by the way, again, we got to reduce the friction between the comments and the code, and we don't want the comments to be wrong. But also this is less complicated. Like I said, in Connect 4 you might have a diagonal that's like 8 spots, and we're just looking for any streak of 4 anywhere in there. So that's why I turned it into a string and used the in keyword. But now we're just saying, is the whole thing all X's? Like with a row, is it all X's? With a column, is it all O's? Okay, so I don't need the in. I could just say equals. I don't really need to make it a string either, but the player name is like a string already, and I'll keep this for now and we can come back. By the way, this uses the any function again because they're saying if any of these equals the target that's like XXX or 000, then we're good. It's really nice, and I would recommend you guys look for opportunities to use any and all because they're just nice. Now the main function is pretty much the same, just like it was in the past when we made a hangman game. You initialize some blanks, you go through a loop, you show the status, get an input, see if we're done, go back around. Pretty much any game, including real-time games. If we're going by frames instead of turns, well, it's still the same idea. You check for input, show the new display, see if we're done, change a few things, and that might be 60 times a second instead of a lot slower, but it's the same idea. So we clear, we print all this stuff, that's probably not going to change. We get input, okay, that's going to have to change a little bit. And then we change the board, that's going to have to change a little bit. But you'll see that at least it's just one. I don't have 10 different functions that change the board. I only have one spot in the whole thing where that modification can happen, so I only have to worry about that one spot. And I only have one place where we get input. It's not here, and then asking again over here, and then all this stuff. So I tried to make it changeable in the first place. So let's ask for 1 through 9, because that's what we're calling these spots, tiles, whatever. And now we have to go back to the validate to make sure it's actually doing 1 through 9. You have to say something that's in that range. So if we try to get -10, that's not going to work. Or if we try to say a blank, it's not going to work. By the way, that's the most common input error, is that you get no input. The person just hits enter without any number in there, and you have to be able to handle a nothing. And then we have to see, okay, can we translate it into the row and column in order to put it in our board, which is going to happen right here. Okay, so let's see. We're going to get the move. We're also going to get the board because we need to look at it to see. So right here, we're using the name column, which doesn't work anymore. I mean, we might have row and column. But first, the move, I'm just going to call it move. I just use the same name we used with the string version for the int version. That might cause confusion, but I'll try it for now. And then we'll say if it wasn't a string at all, or it wasn't an intable string at all, then we say no, that wasn't valid, try again. And then we're going to go range 110 maybe, because remember we don't check the top. And then, okay, here's the point where we have to translate it into 2 dimensions from 1. We have to take that 7 and decide that it's the bottom left. Okay, and luckily there is a function to do this. There's a function called divmod. Divmod is making change. It says take a chunk, or as many chunks as you can, and then you have the leftovers. I did a project last year about making change, so you might get, for example, 90 cents, and you say, how many quarters is that? Plus the leftover. How many dimes is that? Plus the leftover. How many nickels is that? Plus the leftover. And so in this case, we have chunks of 3 to get a row. So if I said 7, I go, oh, that's 2 chunks of 3, because we're 2 rows down. And then do I need to move any over with the leftover? I've also used this with time. If you have a long quantity of time and you need to see how many hours, minutes, seconds, then you can use divmod as well. Okay, so we're going to say row and column equals divmod of move and 3, because it's move in chunks of 3. And then we need to check is the board at that location a blank? Because if it's a blank, that's good, right? That means we can land on that spot. Now when I say blank, I mean an underscore, not a complete nothingness. Okay, so unfortunately, the way I've written it, we're going to have to do this twice. I'm going to have to divmod here, and then also do it outside in the main function, which is really annoying. We should rearrange to avoid that, but for now let's just get it working and see what happens. So this line I'm going to put right here, because the validate used it to check if it's right, but it didn't actually give us the result of that. Which is nice. I like having a function do one job. It's just telling us true or false. It's not giving us a bunch of other things. But for now, we got to do it twice. Let's keep in mind that we'd like to avoid that. Let's see what happens. Run it, you know? So I'm going to say, let's try the top left, and we'll put a 1. No, it's off. It's off by 1. Let's see if that's true for everything. Am I going to go bottom left if I say 7? No. Am I going to go middle if I say 5? No, it's off by 1. And in fact, that's one of the most classic errors in computer science. There's a Wikipedia page about off by 1 errors. And in this case, the reason is because when we made our chart at the top with the 1, 2, 3, we started at 1, but the computer would start at 0 if it was counting that way. So when I say 7, it thinks I have 2 rows and a little bit more in the next, when really I just have 2 rows and nothing. So we need to say -1, I guess. Oh my gosh. We have to do it twice. That's killer. Uh-oh. I need the -1 somewhere else as well. Oh my gosh, that's killing me. So that has to change, which means, okay, finally this does work, and let's do it to the end and see that it wins. Okay, so X wins. This does work, but I'm not happy. I would love to change the validate method to be nicer. Thanks.